Hello and welcome. In this video, we're going to talk about using the chain rule for differentiation. And the chain rule comes into play when we have a composition of functions. So in class, we watched this short video about the peanut M&M analogy for what's the inside function and what's the outside function. So go ahead and check out that video if you haven't. But the idea here is that when we have a composition of functions, when we have something like f of g of x, there's a function that is inside of some outer function. And when this happens, the first thing we need to be able to do is identify which is the inside function and which is the outside function. And then we're going to be able to use the chain rule to actually differentiate. So again, this situation comes into play when we have a composition of functions. There's an inside function and an outside function. So we're going to start by identifying the inside and outside function for these four examples. So the first thing that I'm going to do on number one is I'm always going to rewrite using exponents instead of radicals. So this function is the exact same thing as x minus 4, the quantity x minus 4 to the power of 1/2. So the inside function, the peanut, the inside function is x minus 4. The outside function, the chocolate part of the M&M, the outside function is something to the power of 1/2. So let's look at number two. The inside function is x to the 5th. The outside function is cosine of something, cosine of something. So why don't you go ahead and pause the video and identify the inside and the outside functions for numbers 3 and 4. So we're not doing anything with these two functions right now, but in order to do what we're going to do in this lesson, we need to be able to identify what the inside and outside function is. So go ahead and pause the video. So hopefully you've had enough time to work through this. On number 3, cosine is the inside function. The outside function, what are we doing to cosine? We're putting it to the power of 5. On number 4, the inside function is x squared plus 5x minus 1. And what are we doing to that? We are putting it to the 5th power, which is our outside function. Now that we can identify the inside versus the outside function, let's go ahead and look at how this applies to taking derivatives in calculus. So what we're about to learn is called the chain rule, and the job of the chain rule is to take derivatives of compound functions, or take the derivative of the composition of functions. So just like we did before, we're going to identify our inside and our outside functions, and then we're going to take derivatives based on those. So what we're going to do is we're going to take the derivative of the outside function, evaluate it at the inside function, and then we're going to multiply that by the derivative of the inside function. So it sounds a little bit more complicated than it is, but let's look through some examples and then see how we're doing. For this example here, what's the inside function? The inside function is 5x plus 1. And what's the outside function? The outside function is something squared. So when we take the derivative, when we find f prime of x, we're going to take the derivative of the outside function, stuff to the power of 2. So what is the derivative of something to the power of 2? It's 2 times something to the power of 1, right? We apply the power rule. We drop the 2 in front, and we decrease the exponent by 1. Inside, you're just going to keep the same inside function that you had to begin with. So this part that we just did right here is this part over here, f prime of g of x. Now, we're going to take the derivative of the inside part, which the derivative of 5x plus 1 is just 5, and we're going to multiply that together. So let's clean this up just slightly. This would be 5 times 2 is 10 times 5x plus 1, and we could simplify this down to be just 50x plus 50. 50x plus 10, not 50. 50x plus 10. So again, we're identifying our inside and outside functions. We're taking the derivative of the outside function with the inside the same, and we're multiplying that by the inside function. Let's work through some more examples. All right, let's go ahead and identify the inside function. On number 5, the inside function is 3x minus 1. Then we're going to identify the outside function. The outside function is something to the power of 3. So when we take our derivative, f prime of x, we're going to take the derivative of the outside function. Something to the power of 3 is 3 times something squared. Just using the power rule, the 3 drops in front and the exponent decreases by 1. We're just going to keep the inside function we already had there. And then we're going to multiply that by the derivative of our green inside function, which is just 3. We're going to simplify this just a little bit. 3 times 3 is going to give me 9 times 3x minus 1 quantity squared, and we're going to leave it there. Go ahead and pause the video and identify the inside and outside function. So something that may be helpful to do on number 6 is to rewrite this as tangent of x to the power of 1/2, because then it's really easy to see that the inside function is tangent and the outside function is something to the power of 1/2, which also makes it easier to apply the power rule there. So the derivative of the outside is going to be 1/2 times whatever was inside before to the power of negative 1/2. What was inside before was tangent of x. Then you're going to multiply that by the derivative of tangent of x, which is secant squared of x. And I'm just going to rewrite this as 1/2 times secant squared of x times tangent of x to the power of negative 1/2. All right, let's look at a couple more examples. Number 7, it may be helpful for you to add parentheses here, but I encourage you to pause the video now and see if you can work through 7 and 8 on your own, and then unpause the video and see how you did. Hopefully you've had some time to work through this on your own. F prime of x here is going to equal the outside function. The derivative of the outside function is cosine of what was already inside, and we're going to multiply that by the derivative of what was inside, which is 5. And I like to rewrite this so that my scalar is in front. So I'm going to rewrite this as 5 times cosine of 5x. On number 8, f prime of x is going to equal, I'm going to use the power rule with my outside function, so 3 times what was already inside squared, so x squared plus 1 times the derivative of the inside. Well, the derivative of x squared plus 1 is 2x. And then I'm going to clean this up a little bit. This is going to be 6x times x squared plus 1 quantity squared. So the more you practice and work through this, the easier it's going to be. But really, it's important to start by identifying the inside and outside functions and thinking through the derivative of the outside, keeping whatever was inside the same, and multiplying that by the derivative of the inside. Let's look at this challenge problem before we wrap up the video. It says if P of 2 is 5 and Q of 2 is 3 and Q prime of 2 is 2 and P prime of 3 is 4 and Q prime of 3 is 2/3, that's a whole lot of information. So actually, before I even figure out what it wants me to do, I'm going to organize that information in a table. So I can see that I'm getting different values of P of x and Q of x and their derivatives at different x values. So the first thing I see is all these values when x is 2. So when x is 2, P is 5, and Q is 3, and Q prime is 2. And that, I think, covers all of this information here, because this is all the numbers where there's a 2 being plugged into the function. Here there's a 3 being plugged into the function. So P prime of 3 is 4, and Q prime of 3 is 2/3. So now I think I have all the information I need plugged into this table. And you don't have to start by doing this. For me, it just makes it easier to identify the information that they're giving me. So now we are finding the derivative of P of Q of x, and we're going to find it specifically when x is equal to 2. Well, the derivative of the outside function would be P prime of Q of 2, P prime of Q of 2, and we would multiply that by Q prime of 2, the derivative of the inside evaluated at that value. So let's look at our table to find these values. P prime of Q of 2, which we can get from the table, Q of 2 is 3. And Q prime of 2, which we can also get from the table, is 2. Now P prime of 3, P prime of 3 is here, so that's going to be 4 times the 2 we found in the line before, which is going to give us 8. So sometimes you may be given this information organized in a table format and have to organize that, work through it sort of abstractly because there's no function defined to use to get you to that final answer. Let's go ahead and recap what we learned in this video. We started out by identifying when we have a composition of functions, which functions are inside and which functions are outside. And it's really helpful to write fractions using negative exponents, to write radicals using rational exponents. That's going to make the differentiation process a lot easier, and it's going to make it easier to see your inside and outside functions. We then talked about the chain rule, which says if you have a composition of functions, you're going to take the derivative of the outermost function, keeping the inside function the same, and multiply that by the derivative of the inside function. Then we worked through a lot of different examples where we first identified the inside and outside functions and then found the derivative using the chain rule. So go ahead and write down any questions you have. I look forward to supporting you on this. Thanks for listening.